x cubed minus 7x minus 6 equals to x plus 2 brackets x squared plus bx plus c for all values of x, determine the values of b and c. What this question is actually asking us to do is solve for b and c out of this expression. But we know that b and c, that's two different variables, and at the moment we have just one equation. So what do? This is where a new kind of topic comes in, which is called equating coefficients. This rule states that two polynomials are equal if all the coefficients for the corresponding terms are equal. And by corresponding terms, I mean the same power of x. What that means is if I have something like maybe x squared plus maybe 3x, and I say that's equal to ax squared plus bx plus c, then the only way that those equations can be equal to one another is if the coefficient of x squared is equal to the coefficient of x squared. So a equals to 1 because there's a little invisible 1 there. The coefficient of x has to be equal to the coefficient of x, so b is equal to 3. And the c, the constant term, has to be equal to the constant term here. Since there's nothing there, it would be plus 0, so c is equal to 0. So this is an awesome tool because, as you saw, I had 3 unknowns here. I had a, b, and c. And out of 3 unknowns, I was able to kind of get them out of one equation, because with the equating coefficients method, you're creating more equations than, you're creating one equation for every term in your expression. So I was able to create 3 equations, and hence I was able to find 3 unknowns. So this is the tool we're going to use when we need to find some coefficients of a polynomial. When it shows you that there's 2 things equal in a polynomial, or 2 polynomials like equal to one another, this is probably what you might be doing, is equating coefficients to find the unknowns. Let's begin. I'm going to write out the equation first. Now, I'm going to expand this out because I need to have my terms out like this, all fully separate, so that I can look at them separately and equate the coefficients. So I'm going to need to expand these brackets out. I'm going to do it like this first. So starting with x times x squared is x cubed, x times bx is bx squared, x times c is cx. And now the next one, that's the 2. I'm going to do 2 times x squared is 2x squared, 2 times bx is 2bx, and 2 times c is 2c. Awesome. But I'm not ready yet because I have more than one x squared term and I have more than one x term. I need to collect like terms so that everything has only one of each type of x term. So I'll write out, I still only have one x cubed, but how do I collect my bx squared together with my 2x squared? Just do it on the side, bx squared plus 2x squared. What you can do is bring out the like term, which is the x squared, and then whatever is left goes in the bracket. So I have a b left in the first term and I have a 2 left in the second term. I'm just going to put this bracket first though, because it looks more like a coefficient that way. So the bracket goes first and then the x squared. Okay, similarly I have cx plus 2bx. That's me collecting my like x terms. I'm going to bring the x out to the front and I'm going to have the leftover c and a leftover 2b. And that's my coefficient of the x term. I'm going to put it at the front because order of multiplying doesn't matter, but it just looks a little bit nicer. And then finally I have my 2c left as the only constant term. Just make some space. All right, I think we're ready to start equating our coefficients because we have 1x cubed, 1x squared, 1x, and one constant term. So let's go through and just equate them. At the start of our x cubed term, we have 1 in front of both. So this one's a little bit redundant, but for completion, I'll just write down 1 equals 1. So that's the 1 from this side. is equal to the one from that side. Okay, we probably won't be using that one. Alright, let's look at the x terms. So I have minus 7 equals to c plus 2b. So let's write that out. Alright, I have the constant terms, minus 6 is equal to 2c. And now there's actually something missing. We have to also equate the coefficients for this term, but you'll see that there is no x squared term in this side. It's kind of the same as having plus 0x squared, because there's no x squared term. So I'm going to have on the left hand side 0, and on the right hand side it's equal to b plus 2. Right, so I actually made 1, 2, 3, 4 equations out of one equation just by equating coefficients. That's really awesome. That means we could actually find up to 4 variables if we wanted to, but we only have to find 2. We only have to find b and c. So let's go through, and I can see straight away this one's nice and easy. We can rearrange this to get b by itself just by subtracting 2 from both sides. So if I subtract 2 from both sides, b equals 2 minus 2. Nice and easy. I can also rearrange this one quite easily by dividing both sides by 2. So that gives me c is equal to minus 6 divided by 2 minus 3. Now, because I have these other equations, I should go through and make sure that it's consistent. So I can use this equation to check that my answer is correct. So substituting in, let's start with the right-hand side first. The right-hand side is c plus 2b. So substituting c is minus 3 plus 2 times minus 2. And so that's minus 3 minus 4 is equal to minus 7. And if I double check, the left-hand side of my equation was in fact minus 7. So that verifies that our equations are all consistent with one another, which is a great sign. That means that we've probably found the correct answer. One other way that you can also check, and I'm not sure if I'll do the full thing, is if you wanted, you could write out x plus 2 and then substitute those b's in. So substitute b is equal to minus 2. This is me substituting into the original equation, by the way. Substituting minus 2 and minus 3. And then if you expand this, again, but now you're expanding it with the correct numbers, you should end up with this one, which was this side. So if you're in an exam or something and you have a bit of time, just go through and expand it again, just to double check that you have not made any calculation errors or carried a negative somewhere wrong or anything like that. So this is a good way to double check. This is a good way to really be sure that you've got the right answers. But yeah, this is how you would do equating coefficients.